the assignment now? Let me check if you have got those assignment or not. Okay, Aisha, you have sent the assignment. Let me see. Yes, I have got your assignment. Who else? Ishma, you did not do the assignment, Ishma? Matthew?
I did one question, so I didn't submit it.
Okay, fine. You submit it, okay? You submit it. Send it now. Send it now, okay? What about you, Matthew?
No, sir, my phone is with my dad and I didn't do it because I only got the physics and the biology one. I didn't get the chemistry one.
Acha, okay. So what you are saying, it's kind of not true, Matthew, because
Okay.
if you look at the batch, see. No, this is not yours. No, we have here, yeah. Do you see this?
No, yes, sir. Yes, sir. Yes, sir.
So you have this question, right?
Mm-hmm.
You have this question.
Mm-hmm.
So did you do those? That was the assignment.
No. Yes, sir. I didn't do it. I'm sorry. I've been a bit busy with the school exams. So.
Is that a reason? Huh? It's not a reason, no?
Yes, sir.
Did you read any of those things?
Yes, sir, I did. I went through it after class, and then I moved on to the other subjects. So,
what about today?
Today, no, sir. We had extra class till like 4 to 5. So I'm just coming back from that.
Okay, but take time. It will take
okay, sir.
the day in which my class, the chemistry class is there. Not in fact chemistry, but if you have any class, for example, physics or biology or anything else also, then try to read whatever has been taught in the previous class. When on the days that you have the lecture, okay, on the days that you have the lecture.
Yes, sir.
Yeah, let me start with the. So please solve right now. You know, you can maybe you can join like 5, or maybe you can just put your earphones away from your ears and solve those questions while I'm checking these answers. Okay, this is Samaira, no? I think so. This is Samaira. Okay, so this is kind of right. Kc, it is equal to Kc is equal to only CO2 because we don't have solids in the statements, right? What else we have here? Okay, so AgBr and Ag plus and Br negative, aqueous, aqueous. Yeah, I guess that is also correct. Then next we have CH3. Oh, okay, yeah, fine. This is fine. And what else can we write? CH4 gas, okay, CO2 is gas and H2 is liquid. So CO2, CH4, and just O2. Okay, fine. O2 you have written. Al3 positive. Okay. Then we have H2. Okay, fine. Okay. So you have removed the Al solid from, yeah. Okay, correct. So also correct. That's just cube. Here you have H3O plus. Fine. This is also fine. This is also fine. Okay. Let me check if what. Okay. Aisha, can you please turn the mic on? You were present in the last class, right?
Yes, sir.
Okay. So can you maybe look at the notes and tell me that did I write anything about the solids? Did I write anything about the solids? Did I tell you anything about the solids? What is the concentration of solids?
Concentration of solids is 1.
So why have you written here BaO, which is solid, BaCO3, which is solid? I have also given you an example now how to write the KCs for those things. Yes or no?
Yes, sir. Yes, sir.
Okay, one more thing. Okay, the K that you have written here, it is a capital K, uppercase K, or a lowercase K?
Uppercase K.
Is this uppercase K?
No,
Then
sir.
how do you write lowercase K? Doesn't look like a lowercase, sorry, uppercase K, na? So maybe you write properly, okay? And also one more thing is that the C that you have written, it should be subscript. It seems like you have written like this, KC, okay?
Okay, sir.
Take care of those things also. Again, so these things are all wrong, I would guess, because see, again, AGBR, it is what? It is a solid. You don't have to write this. Again, here, this is a liquid, so you don't have to write this, just pure liquid. Then again, here you have a water, which is a liquid. So that's why you don't have to write liquid. Then here you have what? Aluminium is a solid. Then again, water is a liquid. Okay, you have done this question. So what did you do first here? You calculated the QC. Okay. And what was the QC that you got? You got QC as 100. So QC is greater than KC, right?
Yes, sir.
Okay, so first thing is that this is wrong. Okay, I will tell you why. See here, this is 2 to the power 2, na? This is 2 into 10 power minus 3 square. So you had to have 2 square here and 4 square here, yes or no?
Yes, sir.
So redo this, huh?
Okay, sir.
Redo this.
Okay.
And you will get something else, right? You will get something else here. Okay. Okay, nobody else has done the homework. Sarah, अच्छा, Sarah has done the homework, I guess. उन्होंने किया है कि नहीं किया? नहीं किया है, इन्होंने तो कुछ और भेजा है, पहले का इनका पुराना है. Okay. Why, Sarah? Why did you not do the homework? Yes, Sarah.
Sir, I didn't attend the previous class.
So you get the recordings, yes or no?
Yeah, actually I was sick. So I watched like the first 30 minutes. I have to watch the rest.
What happened to you?
I got fever.
Achha. How are you now?
I'm better.
Better? Okay. So in the last class, we ended up with some applications. Then you wrote the characteristics application of equilibrium constant. And in the application, we did everything, like the two of those, the predicting the extent of reaction and also the predicting the direction of the reaction. The third application is the calculation of equilibrium concentration of reactants and products. Okay, so we'll start with that. So maybe we should start with the topic's name only, write the heading. Okay, so once again, I'm telling, if you know the exam dates for your school now, so please, can you please send that in chat, okay? Send that in chat if you know when are your exams going to be. For Hishma, it is going to be on like this month only, no? I think Hishma has told me that. Yes, Hishma?
Yes, sir.
Okay. So write calculation of equilibrium concentrations. Okay. One more question. Did any one of you completed Thermodynamics NCERT question answers. Did anyone start doing them?
Sir, I started but didn't complete.
Achha. So are you having any difficulty?
No, sir.
कितना किया आपने? एक ही सवाल किया है क्या?
No, so I did like maybe 3, 4, 5 questions.
तो नहीं किया फिर ना, like do, okay? Please like keep on going. 3-4 questions. If you're doing 3-4 questions, then that means you have not done anything, because those must be very easy ones. जो I mean chapter के starting से ही relation होगा जिनका. So please at least do 15-16 and then maybe you can ask me some questions, okay? If you have any doubts. For thermodynamics, I did not tell the Learnivio people to do any numerical classes, because we had done enough numericals in the classroom only, okay? But maybe for equilibrium, I will ask them to hold a session on this Friday. Okay, it will be similar to the states of matter, but equilibrium, chemical equilibrium, then I will be teaching ionic equilibrium, calculation of equilibrium concentrations. So what we are going to do here, we are going to start with the reaction. Okay, we are going to start with the question here. So basically what happens if I have any reaction A to B, and I have been given the Kc, right? I have been given the Kc as something, right? Kc is something, and I have been given the initial concentration. So see, initial concentration will be given, and they will be asking what will be the concentration of reactant and products after a very long time. That means after they have achieved equilibrium, what will be their concentrations? So it is going to be very easy. So you have the initial concentration and then you have the Kc, right? Then you have the Kc. So what you need to do, you need to react, you need to do the reactions, how much moles is going to get reacted. And then by using this Kc, we are going to find the initial concentration and the equilibrium concentration, okay? So let me start with a question. That will be more helpful for you guys. Okay, so right, Kc for the reaction. Kc for the reaction they have given us carbon monoxide, which is a gas, plus H2O in vapor phase, gaseous phase. In vapor phase, it is in equilibrium with CO2 gas plus H2 gas. Kc for the reaction is 4.24 at 800 Kelvin. At 800 Kelvin. So obviously what is going to be in gaseous form? You have to calculate the equilibrium concentration of CO2, H2, CO, and H2O at 800 Kelvin. If only CO and H2O are present initially, and H2O are present initially, at concentration of 0.10 molar each. Okay. So write this question. Let me know if you're done. Done, guys?
Yes, sir.
Done? Okay, fine. So now you see here how we will be doing this question. Please don't write this, okay? I'm explaining a simple reaction. If I have AB, okay, and the K is equal to 1. K is equal to 1, okay? And I'm saying that initially 10 molar of A is present. Okay, 10 molar of A is present. So first of all, one thing should be very clear, that will be having only a reaction from A to B, right? A will be getting converted to B, yes or no? Yes or no, guys? A will be getting converted to B. Yes, okay. And it will be getting converted to B. It will be getting converted to B till the time A, the concentration of A is equal to concentration of B, because K is equal to 1. Because for each molar of B, we should have, this is equal to what? 1 by 1. That means for each molar concentration of A, that means for each mole of reactant, there is 1 mole of product. You got this? Yes or not till here? Tell me. Sir. At equilibrium, we will say at equilibrium, concentration of A and will be equal to the concentration of B, that will be equal to 5, correct? Yes or no?
Yes, sir.
Okay, fine. Now, so this is a very easy question because we had 10 here and the equilibrium constant was very small, and also we had the Kc. The expression for Kc was also very simple. That means you only had one reactant, one product, and the stoichiometric coefficient was also 1. That is why this is very simple, and you can just look and tell the answer. Okay, you can just look and tell the answer. Now, what we are going to do? We are going to devise a kind of algorithm. Algorithm means number of steps, and we will be following those steps in order to calculate the equilibrium concentration if we have been given the Kc and the initial concentration. So we need only 2 things: the initial concentration of whatever product and reactant is given. So here we have been given that only A is present initially, and we have been given the key. So how are we going to do this? So see, so what you will write A, okay, and then you will write this reaction A giving B. Then you will write initial I. Okay, initially what do we have? We have 10 moles of A, and how many moles of B? We have 0 moles of B. Okay. Now in this initial phase, you are writing the concentration. Okay. So 10 molar. If pressure is given, then you will be writing the pressure. So initially what is there, you will write like that. Then you will write the change. Okay, change. Now you tell me, we need to see now how much change is happening, right? When we are going from initial to after a very long time, that means initial to equilibrium, we need to see what is the change happening. Yes or no? So what is going to happen to A? A is going to decrease or increase? In the change, what is going to happen? The number of moles of A is going to decrease or increase?
Decrease.
Decrease. Okay. But we don't know. Do we know how much decrease? In general, I am asking. No, we don't know how much. So we will take that as X. So I will write minus X. Okay, no problem. No problem.
No
Tell
problem.
me, guys. No. Sorry, somebody asked something.
So why minus?
Minus because we are decreasing A, na?
Oh, okay.
Got it? We are decreasing A. Acha. Now tell me if please keep your mics on, na, and tell me if one mole of A is getting converted to B, then how much B will be formed for each moles of A? For each mole of A?
So can I repeat it?
How many moles of B will be formed if 1 mole of A has been reacted according to the chemical equation?
1.
1, right? Because you see in the chemical equation, we have 1A is giving me 1B. But if the equation was something like that, let me change this equation and let me write it like this. 2B, okay? I'm writing 2B. That means for each mole of A, 2 moles of B will be created. Yes or no?
Yes, sir.
Yes, sir.
So I'm writing here. So I have consumed X moles of A. This X and this minus sign means it has been consumed, and I will write plus X moles of B, right? This plus means it has been formed. But one more thing I want to say, that if we had any reaction like this, A is giving me 2B, then I would have written initially 10, here 0. I would have written minus X here, and I would have written plus 2X here. You understand the difference between both of these things? Tell me yes or no.
Yes.
All of you understand this? Okay, fine. Let me change something different. I will write 2A. It is going to give me 1B. That means initially I will have 10. Here I will have 0. And what is going to happen at one reaction event? I need 2 moles of A. I need how many moles of A? 2 moles of A. That is why I will be writing minus 2x, because minus 2x is getting reacted, and how much is going to be formed is x. Yes or no? Any problem in these 3 cases?
No, sir.
No,
No?
sir.
Okay, no problem. So maybe after this question, now after the question that we have written here, what you need to do, you will maybe you take a screenshot of this and you write it later. Okay, so this is the general cases of initial and final. Okay, this is the only thing that you need to know, nothing else. So I will show the question. This is not the question. Okay, I just wanted to prepare you guys for this 2 things: initial and change. Okay. Okay, so can I erase this? Tell me. You take a screenshot, try to remember this, but you can refer back to the screenshot later on. Okay, fine.
Yes, sir.
Okay, so I'm deleting this. Okay. Okay, fine. Now, here also we are going to do the same thing. Sorry. First of all, we have the KC, right? We have the KC. So we don't need to worry about that. We need to write this reaction first of all. So can somebody please dictate me the reaction? Tell me, guys, the reaction that has been given in the question. What is this reaction? Tell me.
CO gas plus H2O gas gives
CO gas
plus H2O gas
plus H2O gas
gives CO2 gas plus H2 gas.
CO2 gas plus H2 gas. Okay. Now I will be writing the initial. Okay. So tell me, what is the initial concentration that they have been given? What do we have for CO? Read the question and tell me. The initial concentration of CO.
0.10.
0.10. But I'm writing 0.10. Please remember that this is molar concentration. What about H2O? What about H2O?
0.10.
0.10. What is the concentration of CO2 initially?
8. Wait.
Sorry, Matthew, what did you say?
With
0, right?
0, yeah.
0, because only CO and H2 are present initially,
Yeah.
right?
Yeah.
So rather than writing 0 or something, you can just write dash and dash. Okay. So these are not present initially. Okay. Now the change. So this is something that you will get from the question, right? This is something, the initial concentration you will be getting from the question. Next is the change, right? Next is the change. Now the change you will be getting from the chemical reaction that you have written. Okay. Change you will be getting. Change is what? Tell me. So see, whatever the stoichiometric coefficient will be there for the reactant, you will write minus x, minus of 1x. Yes or no? Any problem?
Sir, I didn't understand.
You did not understand? Did you understand for A and B?
Yeah, sort of.
Sort of? What about others? Hishma, Samaira, Sara?
Yes, I understand.
Understood, Hishma? What about you?
Yes,
Hishma is not. Okay. What about you, Sara? Sara, आपको आ रहा कि नहीं आ रहा?
sir, I understood that part. Here I'm a bit confused.
Here you are a bit confused. Okay, no problem. Okay, no problem. अच्छा, like it is like आप accept नहीं कर पा रहे हैं या फिर आपको समझ नहीं है. Like अगर आप, I think that it is more of an acceptance kind of thing, not understanding. Because if you understand 8 and B1, then it is the same thing that we are giving. Okay, so Sarah, can you please turn the mic on? I want to talk with you.
Yes, sir.
Okay, fine. So how many moles of CO should react to give 1 mole of CO2? Tell me. No. See, whatever, see, one thing is that I should write it here. This initial, it will be given in question, right? Let me write this here. Given in question. The change that you are writing, it has no relation with initial concentration. Okay. So how are you writing the change? You're writing the change according to the chemical reaction. You understood this, Samaira? Samaira, did you understand this?
Yes, sir.
Okay. What about Sarah?
Yes, sir.
अच्छा सारा आप ये बताइए आप ठीक है आप ये बताइए CO it is going to get consumed or it is going to get produced क्या होगा CO will be consumed or it will be produced in this reaction it is reactant or product Sarah
Reactant.
so reactant gets consumed or it gets produced consumed so minus sign can I write that whatever change will be there it will be the concentration or the amount of CO will be decreasing. Yes or no? Can I write minus sign at least? Okay. So can you tell me how much will be the change?
We have to find out.
Tell me.
It is unknown.
It is unknown, right? So can I write an X here?
Yeah.
Okay, fine. Now again, tell me for H2O. Tell me for H2O. It is getting consumed or it is getting produced?
Consumed.
Consumed. Okay, minus sign then. Fine. Minus sign is fine. Sarah?
Yes, sir.
Okay. So do you know how much H2O will be consumed? Do you know how much H2O will be consumed?
No.
No. Okay. So we can write Y here, but we know one thing that the amount of H2O consumed should be equal to the amount of carbon monoxide that is getting consumed. Tell me, do you understand this or not? Whatever amount of CO it is getting consumed, the same amount of water will also be getting consumed. Because for each mole of carbon monoxide, we need 1 mole of water for the reaction to happen. Yes or no?
Yes, sir.
So can I write minus X here also? Because X moles of carbon monoxide has been consumed and X moles of H2O will also be getting consumed. If X mole of carbon monoxide is getting consumed, yes or no?
Yes.
Any? Okay, fine. You're fine now? Matthew, Sarah, both of you?
Yes, sir. Yeah, now I understood.
Yes, sir.
Yes, okay. So now you tell me how many moles of carbon dioxide will be forming according to the stoichiometry. First, I will write plus. First, I will write plus. Then you tell me.
Plus X.
Plus X.
X, yeah.
Yeah,
plus X.
very good. And here, also plus X.
Yes, plus X.
Right? So please, one thing that you should keep in mind, and maybe you write this, that initially it will be given in the question, and the change it does not have any relation to the initial concentration. It has only relationship with the reaction that we have written. Only it has a relationship with the reaction that you have written and the stoichiometry of those reactions. Okay. Next is the equilibrium. So since I said in the initial class only that we will be looking at ICE, initial, change, and equilibrium. So at equilibrium, so initially I had 0.1 minus X. So X will be changed. This will be at equilibrium. X has been consumed. So this is the at equilibrium. For water also you'll have 0.1 minus X. This is the concentration at equilibrium. For CO2, we have the concentration X, and for H2, we have the concentration X at equilibrium. You understand this point, yes or no?
Yes, sir.
What about you, Sarah?
Yes.
Yes, okay, fine. Now the things are going to be easy because what I can do, I can write the Kc for this reaction. I can write the Kc for this reaction. So what is the Kc for this reaction? We'll write the concentration of products, CO2 and H2 divided by carbon monoxide and H2O concentration, because all these stoichiometric coefficients are 1. Hence, we don't need to write anything. Hence, we don't need to write any power or any exponents. Now, we can write that this is equal to how much we have been given. This ratio, it is equal to 4.24. Right? This is given in the question, 4.24. Now, we also know the equilibrium concentrations, right? We know the equilibrium concentration. So we can write this as, now from the ICE table, what we call this? We call this as ICE table, okay? This is ICE table. So from the ICE table, you will write the equilibrium concentration of carbon monoxide. Sorry, let us start with here. No? The equilibrium concentration of carbon dioxide is how much? X. What is the equilibrium concentration of H2? It is also X. What is the equilibrium concentration of carbon monoxide? It is 0.1 minus X. And this is also 0.1 minus X. And this is going to be equal to 4.24. Okay, 4.24. Now you have X square upon 0.1. This is okay, 0.1 square plus X square minus 0.2X, that is equal to 4.24. Okay. Now here you have X square. It is equal to 4.24 into 0.1 square plus X square minus 0.2X. So you have what? This is quadratic equation, no?
Yes, sir.
So you need to solve this. Yahi hai. I mean, in equilibrium, you need to solve things, okay? You need to do maths. It is going to be like I had bad time with equilibrium only due to some calculations, okay? So please don't get lazy. Calculate, Hana? Calculate this. You understood this, yes or no? First of all, tell me that.
Yes, sir. Yes, sir.
Yeah, okay, fine. So I will give you time. You take time to calculate this one. I just want you to get in the habit of calculation. So you please calculate this one. And after that, I will be giving you a series of questions. What you need to do is you need to end up with this till here. Okay. And then I will move on till here, because this is something that I want all of you to have in your copy. And after that, that is mathematics. That is no more chemistry. Okay. So whatever you have after this, this is mathematics. This is going to be mathematics, because if you calculate the concentration of X, then you can just write the concentration of carbon monoxide, carbon dioxide, water, and also hydrogen gas. Okay. First of all, as of now, calculate X. So kind of you must be using this, Hana? The root for quadratic equation, right? How many of you remember this formula? X is equal to minus B plus minus B square minus 4AC upon 2A. किसी को नहीं याद क्या? Okay. Samaira?
Yes, sir.
You don't remember this formula?
I remember, sir.
You remember. What about Sarah?
Sir, I remember.
You also remember. Wow, Hishma, what about you?
No, sir.
No. Okay. Matthew?
Yes, sir. I remember. It's the quadratic equation.
Yeah, quadratic.
I'm not to find it.
That's good. That's good. I had tough time in 10th standard remembering this formula. Very tough time. I don't know why. I mean, I have a very bad memory for a chemistry teacher. And like while doing equilibrium chapter, then this formula was stuck in my head now. And at that time, I did not forget after that, after doing equilibrium, because we are going to use this formula quite a lot in equilibrium. minus b plus minus the root of b square minus 4ac upon 2a. So I can write this as how many of you are done till here? Can you raise your hand? At least till here. Okay. Okay. ये हिश्मा और समायरा के हाथ पे हाथ रख के बैठे. अच्छा, समायरा is done. What about you guys? Aisha, हिश्मा? अच्छा, हो गया, सबका हो गया. Fine. Okay, no one has. Okay, no one is near to the answer till now. Send me an answer if you are getting any till now. Okay, so here we have 0.8. 0.8, no? So 8, 8, 64. So 0.64, 0.64, 0.64 into, so take 0.05. Should be 25, but 40, so 0.0025. So 0.6425, 6425, 6425, and then I will have 0.8, 0.5, 0.585, so 0.03 into 0.06, 0.06, a 6425. So let me check. Okay, that's approximately fine. 864. 0.50 will be. No one has got the answer till now. Where are you having difficulty? Tell me. How much are you done, Matthew?
Sir, I'm still calculating the equation. I'm doing the root, the calculations and the root. I think
Have
I'm
you
close to the
calculated
answer.
inside the root? This
Yeah,
whole part?
yeah, almost. Yeah, I found one part of it.
Okay, so you're not done calculating under roots. Okay. Anyone who has done calculating under root and they're stuck with how to calculate the square root of something? Tell me about that. No, no one. Okay. Like it's going to be 1 hour and we have done just one question. So also take care of that. How much have you done, Samaira?
Sir, I'm calculating this one.
What? Under root?
Yes, sir.
Okay. What is the square? 0.848. How much did you get?
Sir, I think it'll come 0.719104 whole square.
719. So 0.72. Wait a second. Yeah, approximately I would say that. 72. Yeah, correct. Okay. Are you guys approximating or you are not approximating at all?
No, sir, because this is kind of straightforward, so I'm going a bit accurate.
Okay. Yeah. But again, you can approximate sometimes. Okay. So, for example, how much did you get? 719. Nah? So you can take that as
Yes, sir.
72. You can take
Okay,
that
sir.
0.72. What about you, Sarah?
Sir, I'm solving.
Okay, so tomorrow you don't do anything, okay? Tomorrow, and like for example, if you have time after this class, don't do anything. I will be giving you assignments, I will be giving you questions. You complete those questions, okay? Because once you do at least all the NCERT questions, then it will be fine. So whatever I'm going to give you today, I need those things tomorrow. I need those things tomorrow, okay? From the assignment, all of you, Aisha, Hishma, Matthew, Samira, and Sarah. And please, like, no excuses, okay? No excuses. Okay, hmm. One, two times. Guys, 1 hour is gonna complete. One question only. क्या हो रहा है? बहुत गलती हो जा रही क्या आप लोगों से? Are you doing a lot of mistakes while calculation?
Sir, is it 0.1308 approximately?
So you found out plus or minus?
Sir, it was not required because in the root I got 0. Both cancelled out.
What?
Yeah. Did I do wrong?
I think so. Wait a second. This is small. No, this is going to be small, obviously. Yes, Sarah, you have got the right one, correct one. But one more decimal place, something that you should remember is that at least 2 non-zero digits after decimal point. Okay. So I can see one of them is fine, that is 0.19. And for the other one, can you please extrapolate? What will be after? Oh, one more digit. Yeah, correct, Sarah. Correct. Okay, so let me tell you the answer. You will get 2x. One will be 0.19, and the other x you will be getting is 0.067. Okay, 0.067. Acha. Now, Sarah, you tell me, since you have got the answer, which of the x should I take? Both are real values, right? But which should I take, Sarah? 0.19 or 0.067? Can you tell me?
0.19.
0.19. Why 0.19?
Because it's more accurate.
Okay, wait. Just keep your mic on. Keep your mic on. So you are saying what you are saying, na? That I can remove this x. Wait a second, I need to reshare this thing. Yeah. What you are saying, I can remove this x and can I write here 0.19? That's what we are going to do if I am taking that as 0.19 as x. Yes, Sarah?
Yes, sir.
Can we do this?
Yes, sir.
Okay, see the initial. How much is the initial, Sarah?
0.10.
Acha. So from 0.10, what we are essentially trying to say is that from 0.10, I'm going to react 0.19. Is that possible?
No.
No, no. So now you understand the criteria. How are you going to check whether if you get two values, then always you tally it with the initial concentration. It should be always concentration. So in this case, what we are going to take, we are going to ignore the value of, this is going to be neglected as it's higher than initial concentration. Okay, initial concentration. Fine. So this is going to be our x. So we have the concentration of CO2 and the concentration of H2, which are the products. They will be equal to what? They will be equal to x. Na equilibrium concentration. Equilibrium concentration is for CO2 and H2 is x. So this will be equal to 0.0. Sorry. 0.067. Okay. Next, what do we have? Next, we have the equilibrium concentration of what? Equilibrium concentration of the reactants. Na? Reactants are what? Carbon monoxide and water. Na? So carbon monoxide concentration and this will be equal to the concentration of H2O. And this is going to be 0.1 minus 0.067. So this will be equal to 0.033. You know, this will be also in and this will be also in. Write this down. Let me know if you're done. Done, guys? Yes, Matthew, Aisha, done? Matthew,
Yes,
Aisha,
sir.
Sarah, done?
One sec, sir.
1 second. Okay.
Yes, sir. Done.
Okay. So let us do one more question. So it is done. Written the question, yes or no? All right.
Wait, sir. Still writing the question.
Okay. Done.
Yes, sir.
Okay. So in this question, you can see that we have not been also given the equilibrium concentration, right? We have just been given gram of the gas N2O4. It was placed in this much reaction, this much volume reaction vessel. We have been given the temperature and the reaction. We have not been given the case of it. And they have also asked us to find the partial pressure at equilibrium. That means what is the partial pressure of N2O4 and what is the partial pressure of NO2? Is there a lag in my voice?
Yes, sir.
Yes, sir.
How is it now?
It's all right now, sir.
It's still there? I will join in a while, okay? Let me join
Okay,
in a
sir.
while. How is my voice now?
It's okay, sir.
It's okay. Okay, fine. Wait a second. Okay, I can share my screen now. Okay. So first of all, what we need to do is to calculate the KP. Okay, calculate the KP because we have been given the total pressure, right? We have been given the total pressure. Now, before anything else, before calculating KP and KC or anything else, we need first of all for KP we need the pressure, and we have been given only the mass here. So first of all, we will convert this to number of moles. Then we will use the PV is equal to nRT, that is the ideal gas equation, and then we can calculate the pressure at equilibrium for N2O4 and NO2 also. Okay, so first of all, right, the solution part, the number of moles of N2O4. Since PV is equal to nRT, PV is equal to nRT. What do we need to find? We need the pressure in order to calculate the Kp. That is why we need the number of moles, and we know the number of moles, it will be equal to the given mass, that is 13.8 divided by N2O4. So nitrogen 92, right? N2O4 molar mass. Can somebody calculate?
Yes, sir. It's 92.
92. So is there any way that this can be eliminated? What is 13? 138, 130. Okay, 13 and we have 92. So 1 za it will be 92. Can you calculate this and tell me? Yeah, any luck?
It's 0.15.
0.15 moles. Okay. And then we can put P is equal to number of moles is 0.15. Or we are going to take that. This is bar, na? So we are going to take what? 0.083. 0.083 into the temperature is 400 Kelvin. Take 400 Kelvin. The volume is 1 liter. So we don't need that, but still 1 liter. Okay. Now you will get the pressure in terms of bar. We're getting pressure in terms of bar. So tell me, let me calculate this. Okay. This is 4.98 bar. Okay. 4.98 bar. Fine. So this is the partial pressure of what? Partial pressure of N2O4. Okay. This is the partial pressure of N2O4. Now, that means this is the initial. And initially we took this much. So this is the initial pressure. Initial pressure. Now what we need to write? We have got the initial pressure. We will write the equation. The equation is N2O4. It is going to give me 2NO2. 2NO2. The initial is going to be what? Pressure. Now, what is initial pressure? 4.98. And here it will be nothing. That is 0. 4.98. And here it will be 0. The change. So here the change will be of minus x. And here there will be a change of plus 2x. Yes or no, guys? Any problem till here?
No.
Tell me. No, no. Okay. This will be 4.98 minus x. And this will be what? 2x, right? 2x. This is the equilibrium pressure. This is the equilibrium pressure. And they have said that at equilibrium, total pressure, it is equal to how much? I think 9.15 bar. No? Yeah. Total pressure is equal to 9.15 bar. That means this pressure plus this pressure is equal to 9.15 bar. That means I can write 4.98 minus x plus 2x. It is equal to 9.15 bar. Okay. Whatever you are going to get, that will be in bars. So this will be equal to how much? So x, it will be equal to 9.15 minus 4.98. Yes or no? Correct?
Yes.
Guys, what happened? Any problem till here?
No, sir.
No, sir.
No problem, no? So 9.15 minus 9.5. 4.98 only, no? Yeah, 9.15 minus 4.98, yeah. So this will be equal to how much? 8 5 में 7 5 8 7 no? Then 1 4.17. Correct? 4.17 only, no?
Yes, sir.
Okay. So we have got the equilibrium pressures, right? So at equilibrium, what is this? This is X at equilibrium. The pressure of N2O4 is equal to 4.98 minus X. And the pressure of NO2, it is equal to it is equal to how much? 2x. So this will be equal to 4.98 minus 4.17. It's going to be how much? 0.81, no? 0.81, 8 and 1. 81 इसमें डाल देंगे तो आ जाएगा. हाँ, आ जाएगा. This is 2 into 4.17. And this will be equal to how much? 34 and 8, no? So 8.34. Fine. Any problem till here?
No.
No, sir.
No problem. Okay, fine. Now you have the KP. So KP, it is going to be the product's concentration. What is the product? The pressure of NO2 to the, this will be square divided by the pressure of N2O4. So pressure of NO2 is how much? Pressure of NO2 is going to be 8.34. 8.34 square divided by 0.81. Okay, 0.81. So we'll get this number, whatever the KP is, and you know the KP, it is equal to KC times RT to the power delta NG. Now you can write that from here KC will be equal to whatever KP you are getting from here divided by the RT times delta NG. Okay, so write this to here. You can solve from here, right? You can solve from here. Done?
Yes, sir.
Okay. Right, next. Let me give you guys homework here only, है ना? So we have done 2 problems for NCERT. Okay, wait a second. Okay, so this is one of the questions that you are going to do. You can also maybe, if you want, you can take this in your NCERT textbook. Okay, let me give you some more. Do we have any? There will be more in the exercise, I guess, now. Example system. Okay. Okay, Ishma. So you start with 7.8, okay? 7.8, 7.9, 7.10, 11, 12, 13. So all these questions till 7.23. Okay, so you can start from 7.7, I guess. 7.7. 7.8. Yeah, 7.8. This is from exercises, okay? So you have how many questions? 16 questions. So what you do today? Today you have to do 8. Tomorrow you will do 8. Okay. Then on Wednesday you will send. Will that work? Hishma, Matthew, Samaira, Sarah?
Yes, sir.
Today 8, tomorrow 8, and then on Wednesday. So maybe tomorrow we have classes, na? Samaira, Sarah, Hishma? Tomorrow we have one class now, organic chemistry.
Yes, sir.
So I will not take their class, but please do these questions. Will that be fine?
Yes.
Okay. So I'm giving you guys time. Please do them. Today 8 and tomorrow 8. Okay. Right. Next topic that we have already seen this. So I will not be spending much time, but it should be there in the equilibrium chapter. That is why I'm writing this. Relationship between Kc and delta G. Between Kc and delta G. Equilibrium constant and delta G. So we have seen this where in the thermodynamics. So we know that delta G, it is equal to delta G naught plus RT ln Q. RT ln Q. Now at equilibrium, nothing is happening. That is why no change is going to happen. Okay, this delta G is for the reaction. Delta G naught is for delta G naught ka value aapko, you will get that in the record books because that is a reaction that is happening at the standard conditions. So you will have some value for delta G naught. Okay, so delta G naught is going to have some value, but at equilibrium, so delta G naught has nothing to do with the equilibrium. Delta G has to do something with the equilibrium, not delta G naught. Okay, so at equilibrium, the delta G is just going to be 0. Delta G is going to be 0. And that is why we can write 0, that is equal to delta G naught plus RT ln K, right? Because at equilibrium, the Q becomes K. Then you can write delta G naught. This will be equal to minus 2.303 RT log of K. RT log of K. Now from here you can say that log of K, it is going to be equal to what it is going to be equal to. It is going to be equal to minus of delta G naught divided by 2.303 RT. Yes, guys, equal to this much. Then you can write this is the base 10. Okay, this is base 10. So you can write the K is equal to 10 to the power of minus of delta G naught divided by 2.303 RT. Write this down. Let me know if you're done. Done all of you?
Yes, sir.
Yeah.
Okay. Right, next. Now I'm going to ask you a few things. Okay, I'm going to ask you a few things. Again, we are going to take a simple reaction. A, it is going to give me B. Okay, A and B, they both are in equilibrium. Both of them are in equilibrium. Achha. If I tell you, what will happen after it has achieved equilibrium. Okay, so nothing is happening now. Is that fine, everyone? Nothing is happening now. Tell me.
Yes, sir. Yes, sir.
Yes. Okay.
Mhm.
Now I added some moles of A. What did I do? What did I do? I added some moles of what? Some moles of A. What did I do, guys?
You added some moles of A.
Some moles of A. So something is going to happen, nothing is going to happen. Tell me. There are only two things. Anna? Will something happen?
Yeah.
What will happen?
The reaction with B will increase. So
Yeah, that means A will be getting converted to B now. Yes or no?
Yes.
Yes, guys. All of you agree?
Yes, sir.
Yes. Okay, fine. So you see that what I did, I influenced this equilibrium, right? What did I do? I added some concentration, and if I added reactant, then I was going to get the reaction was going towards the direction of product. If I will add some product, then the reaction will go from product to reactant. Yes or no?
Yes, sir.
Yes. Okay, fine. So this is one thing. What is the effect of the change in the concentration of products or reactants? So if I'm changing something, what is going to happen? If I'm changing something, what is going to happen? Okay. Now let me ask you one more thing. Let me ask you one more thing. What if I remove some of the B? What will happen? What will happen if I remove some of the B? Then what is going to happen?
A will also decrease.
That means A will be getting converted to B.
Yes.
Right. So what will happen? How the equilibrium? See, equilibrium, it has to be maintained at any, I mean, if you change anything, that means there will be something happening in the system that will be taking the system towards the equilibrium. If you are changing, if you are altering the equilibrium condition, then the system, it wants to be always in equilibrium. So system will do something to attain equilibrium. So now we have to put our mind in, and you have already answered many things. Now that means if I add A, then the reaction will go to the forward direction. If I remove A, then the reaction will go towards the backward direction. If I add B, then the reaction will move towards forward direction. If I remove B, then the reaction is going to be the backward reaction is going to be. If I remove B, then the forward direction, right? So anything, the equilibrium, the system, it will do something to again attain the equilibrium. It is going to attain the equilibrium. Okay. Next thing is that this is the effect of change of the concentration. It is the effect of the change of concentration. What if we change the temperature? What is going to happen if I change the temperature? Now, if I'm going to change the temperature, then we have to know about the exothermic and the endothermic. Which of the reaction is exothermic and which of the reaction is endothermic? Where is the heat involved? Because if you remember thermochemistry, the thermochemical reaction which includes temperature and heat, then something is like, it is something like that, right? A plus B, it is going to give me C plus some heat. You remember this? Yes or no?
Yes, sir. Yeah.
Right? Either, so in this reaction, this is an exothermic reaction, right? Because the heat is in the product.
It's giving out heat. It's creating heat.
It is giving out. Yeah, very good. Now, if I do A plus B plus Q, it is going to give me C. That means it is now endothermic reaction. That means we are putting in heat. We are putting in heat. Okay, we are putting in heat. So let me delete this and let me go towards the next. Just increase the size here. So I am saying that A to B, it is going to be exo. Okay. And B to A, it is going to be endo. It is going to be endo. So what is going to happen if I will heat this system? What is going to happen if I heat this system? Think about it for a while.
Be endothermic.
Be endothermic?
Yeah, because you're heating the system, right? So you are putting in heat.
Yeah, I'm putting in heat. So see how you have to look at this now. See how you have to look at this. What I'm saying that A to B, it is giving me heat, right? And if I write the backward reaction, that means B plus some heat, it is giving me A. Yes or no, guys?
Yes, yes.
Yes, all of you fine with this? Tell me. So if I increase the temperature, that means I am heating up the system. It means I am increasing the product. Yes or no? I'm increasing the product.
Yes, sir.
Right? Because heat is in the product of this reaction. Correct, guys? B plus Q is what? B is in the product. Okay, this is the product. अच्छा आप लोगों को ये reactant लग रहा होगा. B is the product here, right?
Yes, sir.
Hishma, yeah. What about you guys? Aisha, Hishma, Samaira.
Yes, sir.
Right now. So what I'm doing, if I am increasing the temperature, that means I am increasing the product. In this particular case, where we have the backward reaction as endothermic. So the backward reaction, the rate of backward reaction will increase, right? So more and more B will be converting to A because we are increasing the product. The same as we are increasing the concentration of B, what is happening? Backward reaction is going to get higher, right? We are going to have backward reaction if I increase the concentration of B. Why? Because it is in the product. And if I increase the heat, I'm also increasing one of the products. In terms of energy, in terms of heat, we are increasing the product. So what is going to happen? The backward reaction is going to happen. Have I made this clear? Yes or no?
Yes, sir.
Yes, sir.
Okay, fine. Now, if I increase the temperature, so we have got also the effect of temperature. Now, if I decrease the temperature, just the opposite thing is going to happen, right? If I decrease the temperature, then the A to B is going to be faster. A to B is going to be faster. Okay. And B to A, less and less of B to A is going to be formed, less and less B to A. So let us write these two things. And this very simple, this very intuitive, right? Yes or no? Tell me, guys.
Yes,
Intuitive.
sir.
If you would have, let us say, spend 5 or 10 years in chemistry, I am pretty sure you would be able to come to these conclusions. Yes or no?
Yeah.
That's fine. But now this is a principle in chemistry, but we will not look at this as a principle. You will not give the reasons as Le-Chatelier's principle. If you are asked why this is happening in equilibrium, you will not just say that it is Le-Chatelier's principle. You have to know what is going inside the system. Okay, it is going to inside the system because Le-Chatelier was not the one who was deriving the equilibrium. The system, the universe, it derives the equilibrium. So you must know what is happening inside. Okay, you must know what is happening inside and why it is happening inside. The answer, you can say for a few words, you can say Le-Chatelier's principle, but you need to explain this. Okay, you need to explain this if somebody asks. So, right, the factors affecting, this mainly is factors affecting the state of equilibrium. So that type of thought experiments that we did right now, what will happen if I increase the product concentration? What will happen if I increase the reactants concentration? So Le-Chatelier was the one who did the real experiments. So we did just thought experiments and we concluded. Le-Chatelier was the one who did some real experiments and he came into these conclusions, right? Whatever you said already, Factors affecting the state of equilibrium. And the next is, this comes in the Le-Chatelier's principle. So, any guess? Le-Chatelier is from which country?
France, maybe, because of his name.
Yeah. Le-Chatelier's principle. Because of this word, no?
Yeah.
Matthew?
It's either France or Belgium. It's more likely to be France.
Yeah, more likely to be France. So you are into memes? Seems like that.
And but then I'm kind of into geography too. So.
So yeah, okay, fine. So Le-Chatelier's principle. Okay, so it states that we need to write this. I hate these type of very logical principle. You will see something like Markovnikov's rule and anti-Markovnikov's rule in hydrocarbon, which are just very logical things that you should derive with yourself. You do not need any Le-Chatelier or any Markovnikov or Seltzev. So please write if a system is in equilibrium, if a system in equilibrium, if a system in equilibrium is subjected to is subjected to a change in any of the factors, that determine the equilibrium, condition of a system, that determine the equilibrium conditions of a system, then the equilibrium will shift in the direction, so as to reduce the effect of change. Okay. I don't know, very vague kind of statements. We will have more clarity when we write the factors, right? Just the examples that we did right now, we will write those things. What will happen if I increase the concentration of the products or reactants, or if something is added or if it is removed, okay? Write this down, let me know if you're done.
Answer.
Done?
Yes, sir.
Okay, right now. The effect of change in concentration. Number one. Effect of change in concentration. So you can write, there are, you can write like two things. Increase in concentration of any of the reactants, what it will do will shift the equilibrium to forward direction. Okay. Now, if there will be increase in concentration of product, rather I should say any of the product, then the equilibrium will shift to backward direction. See, if there will be a decrease in concentration of reactants, then equilibrium will shift towards forward, like towards backward direction, because we need We have decreased the amount of reactant. We need to increase the amount of reactant now. Shift towards backward direction. Deeper. Sorry. Decreasing. Concentration of product. Then equilibrium will shift towards forward direction. Done, guys?
Yes, sir.
Yes.
Done.
Okay. What is the next? Temperature, right? Effect of temperature. Is it right A or B? Right one. Effect of. Effect of temperature. So how can we write this? Write A part. Increase in temperature. Leads to shift of equilibrium towards exothermic direction or reaction. Because we have put in temperature, we need to remove that temperature because the equilibrium should be maintained. B is that decrease in temperature. Leads to shift of equilibrium towards endothermic reaction. Okay, towards endothermic reaction. Right, note. So if we have an exothermic reaction, okay, if we have an exothermic reaction, and what do? We decrease the temperature, right? We decrease the temperature, then the reaction will be more and more exothermic, right? It will be more and more exothermic, and that is why you can say the equilibrium constant of an exothermic reaction, it decreases as the temperature increases. You can write here the equilibrium constant of an exothermic reaction. Wait a second. The equilibrium constant of net exothermic reaction. Net exothermic reaction, that means what? The delta H of that reaction, the whole reaction should be negative, okay? Not one direction. I'm not talking about a direction. I'm talking about a complete equilibrium reaction. Okay. A to B. If A to B is exothermic, the equilibrium constant of a net exothermic reaction will decrease on increase in temperature. The equilibrium constant of net endothermic reaction, the reaction whose delta H is positive, it will increase on increase in temperature. Okay, an increase in temperature. Okay, so let me know if you understand the last 2 points, the note. Or should I mean, do I need to explain this? Please let me know. I feel I need to explain this. Matthew, Samaira, Sarah, Vishma, Aisha, all of you understood this? The last 2 points?
Yes, sir. Yeah.
No, you understand why is it happening?
I don't understand why it's happening, but I understood the point.
You will obviously understand the point. It is plain English.
Yeah.
Okay, fine.
Yeah.
Okay, so I mean that you understand the reason or not. What about others? Sarah, Samaira, you understand the reason why?
No, sir.
No, okay, fine. So have you written this?
Yes, sir. Written.
Okay, fine. So whenever I ask me, you understand this or not, I mean the reason, okay? I mean the reason. Okay, so I have here A to B. And I see that this is exothermic. Okay, fine. So what do I mean by this reaction is exothermic? It means that the net reaction is exothermic. If I go from A to B, it is completely exothermic. Okay, any problem till here?
No,
No,
sir.
sir.
No problem, no problem. So if I will increase the temperature, what is going to happen? B will be getting converted to A. Yes or no? More and more backward reaction will happen. Yes or no?
Yes, sir.
So if I increase the temperature, the concentration of product will decrease.
Yeah.
Yeah. And what is K? It is the concentration of product divided by the concentration of reactant. So if the product concentration is decreasing, the K will decrease. Yes or no?
Yes.
All of you get this? Yes or no? Tell me.
Yes, sir.
Okay. Now let us see the different case. If we have this as endo. If this is endo, then what is going to happen here? If this is endo, then if I will increase the T, then what is going to happen? A to B, more and more A to B will be formed. Because this, if I'm increasing the temperature, I'm giving it heat. If I'm giving it heat, that means more and more forward reaction will happen. Because, tell me yes or no.
Yes,
Yes,
sir.
yes. Yeah.
Yeah. Okay.
So
if I increase
because the P
temperature,
will increase and then the K will go down.
K will also increase. No, B increases, right? Product is increasing. So K will be product upon reactant. So if product is increasing, the reactant will also, the K will also increase. So for endothermic, if you increase the temperature, the K increases. But for exothermic, if you increase the temperature, what happens? The concentration of product, it will decrease, and hence what will happen? The K will decrease. Got it, all of you?
Yes,
Yes.
yeah.
So maybe what you can do is, let me delete this, and rather you should write something more tangible. So for exo, the T increases. Okay, if the T is increasing, what is happening? Backward reaction increases. Back reaction increases. If back reaction is increasing, the concentration of product is decreasing, and that is why what is happening? The K also is decreasing. For endo, if the temperature increases, the forward reaction increases. Hence the concentration of, concentration of product is increasing. And what is going to happen? The K is also going to increase. Okay. This is for endo. Done, all of you?
Yes.
Yes, sir.
Okay, chalo, fine. Thank you very much. Let me stop sharing this.